Good afternoon, everyone. Are you able to see my screen?
Yep.
Okay. Welcome to the Database Professionals virtual meetup group. My name is Julie Bloomquist. I'm one of a team that helps keep this virtual DBA group going. We want to really thank you very much for joining us today. Here are the links. You can see where we are on Meetup and our LinkedIn group. You can just swipe the QR code to get that. Please spread the word about this new platform that we are over on Meetup. We were formerly through the PASS organization. Our meetings are the second Wednesday of the month at noon Eastern time and the fourth Wednesday at noon Pacific time. Recordings are now going to be available, and here's the tiny URL for that. And then the slides and demo code will be over in this location. Here's a list of our future sessions that are coming up. Got some great speakers from around the world. And we might have a slot available. If not this year, for next, send an email to the DBA-VUG at outlook.com and if you're available or would like to speak to the group. SQL Saturdays and Data Saturdays are one-day mini conferences. Here's some that are coming up in different areas around the world. A lot of them are held in English, but it's an opportunity to do a one-day conference, and a lot of them are still doing virtual. Whoops. So I wanted to thank you for joining, and I'm going to pass it over to Nikola. Stop sharing my screen.
Okay, hope you can see my screen now.
Yes.
Okay, awesome. Thanks, Julie. Hi, everyone, and good evening or good morning or good afternoon from my side, depending on which part of the world you currently are. It's 9 p.m. here in Austria, where I'm located. So good evening here from Austria. And I'm extremely happy to be with all of you here virtually, of course, and chat about technologies and products that I truly adore. So today I want to talk about Azure Synapse Analytics, or to be more precise, about Serverless SQL pool within Synapse Analytics. And before we dive into a real fun, I just wanted to give a credit for this part of the session title, It's Just a SQL. As far as I know, this belongs to Microsoft's Anna Hoffman, who famously said that when asked to explain the difference between on-prem SQL Server and Azure SQL Database, and I thought it completely makes sense to use this sentence as part of the session title, as probably a lot of you are now asking yourselves, what is the difference between SQL Server and Serverless SQL pool? So don't be afraid, as title suggests, it's just a SQL. Before we start, let me just briefly introduce myself. My name is Nikola Llic. I'm originally from Belgrade in Serbia, but for the last more than 5 years, I live in the wonderful city of Salzburg in Austria. Living in Salzburg was the reason why I've chosen my nickname Data Mozart. I guess you all know that Salzburg is worldly famous as a birthplace of Wolfgang Amadeus Mozart. So I was brave enough to use his last name as part of my nickname. And that's why my motto is make music from your data. You can find me on web. I'm regularly blogging at data-mozart.com. I'm also active on social media like LinkedIn and Twitter, so feel free to connect if you like. Few more sentences about me. I have multiple year experience working with different data products, predominantly Microsoft Data Platform. Started with SQL Server, then brushed myself with analysis services, multidimensional reporting services, integration services. In the last few years also with PowerBI. Other than that, I'm a Microsoft Data Platform MVP and Microsoft Certified Trainer. Privately, father of 2 kids and true football and Barca fan, as you can conclude looking at the photo on the screen. So let me briefly walk you through the contents of our today's presentation. We will start with quick comparison between traditional and modern data warehousing concepts, just in order to put our discussion in the proper context. Then I will introduce you with Azure Synapse Analytics and core components of this platform, which will enable you to better understand the next unit. What is a serverless SQL pool? Why should you consider it for your analytic workloads? And finally, in which scenarios would it make sense to go this path? We will then examine different techniques of using T-SQL to retrieve the data from semi-structured and non-structured data sources, such as CSV or Parquet files, or even NoSQL databases like Cosmos DB, for example. In this part, we will see which tools we as SQL developers have under our belts when dealing with those challenges. Straight after that, I will cover the best practices for using Synapse Serverless SQL pool and how to get the maximum from this engine. Last but not least, as I'm sure that most of you folks are most interested to hear how much this costs, we will talk about pricing, what counts for the billing, and how to manage your costs, and finally how to save money in your wallets. There will be a few demos along the way so you can get a better feeling of different features within Synapse Serverless SQL pool. Okay, so here we are. Once upon a time in a far, far away land. Just kidding, of course, our story doesn't start like that, but our story starts with a quick look back to some concepts that were and still are omnipresent in the world of data. These days, I assume you are familiar with this, there are a lot of many new phrases, concepts like data lakehouse, data mesh, data this, data that. I will not go into discussions and explaining each of these concepts. If someone asks you, is traditional data warehousing dead? It's not dead. It's far from being dead. It's more in, let's say, evolution phase, adapting to many new challenges, typical for large data volumes or different flavors of data sources. Let's put it that way. So in a typical traditional data warehousing scenario, as you can see in this illustration, you would go and collect your data from various different sources, perform some transformations, data cleansing, stuff like that, before putting that consolidated data into a relational data warehouse. This relational data warehouse, this was and still is the focal point of your reporting solutions, a so-called single source of truth for your data, and you could go and build various reports from there using a whole range of different tools, such as, if you're old enough like me, Crystal reports or SQL Server reporting services or PowerBI, if we talk about Microsoft's solutions. You could also build an additional semantic layer using SQL Server analysis services or Azure analysis services to create cubes or tabular models, and then target those cubes with reporting tools that I previously mentioned. And don't forget good old Excel too as a reporting tool. And if you think of a traditional data warehouse, as its name suggests, like of a warehouse, you are close to truth. It is like a large store. And modern data warehouse is like an extra big distribution center. In this traditional large store, products are already unpacked, prepared, and ready for use. So it's like someone extracted them from the boxes, transformed their original package, and loaded the shelves in the store, and they're ready for consuming. I assume you get the analogy with extracting, transforming, and loading ETL stuff in traditional data warehousing concept. On the other hand, in this big distribution center, well, you see how the items are being stored there. But if you need a box, let's say of a beer or Coca-Cola, you can go and pull it directly from here without needing to go to your local shop to take it from the shelf. And as you may see in this illustration, modern data warehouse accepts data from the whole range of different sources, structured, semi-structured, non-structured. And this can be, for example, graph-like data coming from social networks, data streams from different devices, data from JSON documents, CSV files. So literally anything you can imagine that is capable of storing some kind of data. Now this big distribution center can keep the data in its original form, without need to apply some additional steps in order to prepare this data for further analysis. So whole range of different data professionals can benefit of having a solution like this. For example, data analysts can use Power BI or similar reporting tools to create reports over this data, while data scientists and machine learning engineers, for example, can create and train their models right away. The key concept here in modern data warehousing is that unifying experience that the modern data warehouse provides. With that in mind, there are multiple benefits that modern data warehouse brings. From a technology perspective, modern data warehouse brings the following advantages. It is always or almost always, let's say, available. It scales to extremely large amounts of data. It's also flexible because you can quickly get insights from literally any data source. And that brings us to another important point. Less time is needed for data movement and data preparation, which in the end brings reduced overall ownership costs. Now, I want to ask you a question. Do you recognize these objects on the screen? Yes, exactly. That's the famous Swiss knife. You can use this device to cut the paper. You can open a bottle of wine or beer, or even you can cut some smaller items, and all of that using just one single tool. So if you are asking yourself now, what on earth does Swiss knife have in common with Synapse? Well, you can think of Synapse as a single tool that can satisfy all your data workload needs. Do you need to import data from multiple different sources? Synapse can do that. Do you need to transform data before serving it? Synapse can do that too. Do you need to store the data? Synapse can do it for you. Do you need to query non-relational data or even files directly? Synapse can do that. Watch out now. Do you need to query non-relational data or even files directly using plain old T-SQL? Synapse can do that. What? Yeah, I hear you. Say it again, Nikola. So I will say it again. Yes, you can write T-SQL to query data from CSV, from JSON or Parquet files, but more on that in a few minutes. Do you need to build machine learning models? Synapse can manage this for you. Finally, do you need to create your Power BI report straight from the Synapse? Yes, that is also possible. As you may conclude after all this story, Synapse is a one-stop service for all your data tasks. Or if someone asks you to define Azure Synapse in 3 words, you can freely tell that it's an end-to-end analytics solution. Okay, so here is the quick, I like to call it 10,000 feet high overview of different components that make Synapse Analytics integrated analytics solution. For SQL professionals, there are 2 pools in Synapse. Dedicated pool is the official successor of former Azure SQL Data Warehouse. And then there is a serverless SQL pool, which will be the focal point of our today's talk. Don't be confused with this naming. I apologize, this is a bit outdated illustration. In the beginning, when Synapse Analytics was still in public preview, serverless SQL pools were called on-demand pools. That's why this title here. But on-demand pools equals serverless SQL pool, just to be clear. Then folks familiar with Python, Scala, or Spark SQL can leverage usage of Apache Spark pool for processing large volumes of data. When it comes to storage part, there are also a bunch of possible options to choose from, starting with traditional relational way of storing data in a SQL data warehouse, then also Spark tables, Azure Data Lake storage Gen 2, or all the way to non-relational document style storage mode in Cosmos DB. You can also orchestrate data movement using Azure Data Factory pipelines and mapping data flows. Finally, as I already mentioned, you can visualize your data using, for example, Power BI. And watch out, here is the key takeaway. You have all these tools under one roof, either natively, either as linked services. And you can build, manage, and deploy your end-to-end data solutions from within a web-based user interface, which is called Synapse Studio. We will take a closer look to this tool later in the session, as we now need to lay some more theoretical background. As you may notice in the previous illustration, Synapse Analytics offers 3 different analytics pools for performing different computations over your data. 2 of them are SQL based, dedicated SQL pool and serverless SQL pool, which means that you can use familiar T-SQL syntax for querying the data. Also, 2 of them are provisioned dedicated SQL pool and Apache Spark pool. That means you need to set some kind of infrastructure in advance. And more important, that means that you will be charged not only for computing power, but also for the storage you are using. Again, before we dive deeper into a detailed overview of the serverless SQL pool, let's take a quick look from our aeroplane on its architecture. The core component of serverless SQL pool is a distributed query processing engine called Polaris. So this is a completely new thing that Microsoft product team developed for this architecture. And this engine separates compute and state for cloud native execution. Polaris engine runs on control node. So here on this one. And this control node represents practically the brain of the whole architecture. And this control node interacts with all the applications in order to optimize and coordinate distributed execution of the query. So control nodes splits the query into smaller chunks and forwards them down below to compute nodes for execution. It also assigns a set of files to be processed by each compute node. So instead of query, like we had in traditional SQL Server, we have something which is called task. You can think of task as a query. And task is nothing else but a unit of distributed query execution. Last but not least, unlike in dedicated SQL pool where you are in charge for defining computing power and how many compute nodes will be used, serverless SQL pool scales automatically to support your data workload. In case you're interested to learn more about Polaris engine architecture and the details how it works, I provided a link to a white paper in the slide, so please feel free to refer to it and find how it works under the hood. Okay, so I promised in the beginning when I was introducing the agenda that we will try to answer to 3 key W's regarding serverless SQL pool. And those 3 W's are what, why, and when. So let's start with what, and I will try to keep this as short as possible, I promise. So serverless SQL pool is essentially a distributed data processing system, or maybe it's better to say a query service that enables you to query data directly from the data lake using well-known T-SQL syntax. There is no any costs for the resources, storage, etc. You will be charged only for the amount of data processed by running your queries. We will examine later what counts in the amount of data processed and how you can control it. At this moment, just keep in mind that serverless SQL pool is a typical pay-per-query model. In the end, you can think of serverless SQL as advanced version of Polybase if you're coming from traditional SQL world or cloud Polybase. Underlying technologies, to be honest, are not the same, but use case scenarios are pretty much the same. So in Polybase, you don't have open row set function to perform ad hoc analysis, as everything is handled through external tables. But yes, in the end, the logic is similar, and you can think of serverless SQL as Polybase on steroids. Now, as we hopefully answered what is serverless SQL pool, let's try to examine why you should consider using it. First and most important, you don't need to set up any kind of infrastructure or clusters or things like that to make this thing running. Once you create your Azure Synapse workspace, serverless SQL pool will be created by default, just like that. That means you can start querying your Azure Data Lake storage as soon as you create the workspace, and that significantly reduces time to analysis. As I already mentioned, when you provision dedicated SQL pool or Apache Spark pool, you will pay not only for computing power required to satisfy your data workloads, but also for the data storage. Here, with serverless SQL pool, you pay 0 for the data storage. Finally, learning a new programming language just for querying data from the data lake let's be honest, can be daunting for many professionals, especially those coming from the SQL world. Therefore, a big benefit of Serverless SQL pool is the possibility to use a well-known T-SQL syntax to retrieve the data directly from, let's say, CSV or Parquet files, or even from the documents stored in Cosmos DB. Okay, so in full honesty, Serverless SQL pool is of course is not a magic wand that will solve all your data requirements. So it's extremely important to understand in which scenarios you should consider using it. So let's try to answer our final W. When would you use Serverless SQL pool? First scenario, I need to gain a quick insight into the data that is stored in my data lake. Let's say I want to see maximum or minimum value within a column, or quickly identify some outliers. I can go and perform basic data exploration of the data that is stored in CSV or JSON or Parquet files using Serverless SQL, and then based on those insights, I can decide how to leverage this data for further analysis. Next one, I want to build a kind of relational abstraction layer on top of many disparate data sources that are stored in my data lake between, let's say, CSV files or Cosmos DB or even relational data. And this way I can build a logical data warehouse without needing to physically move or transform data in traditional, this classic ETL way that we know. Finally, I want to perform simple, but at the same time scalable data transformations within the data lake itself using the language I know, and that language is T-SQL. So as I go and transform my data, it is quickly available for further consumption by either reporting tools like PowerBI, or I can decide to load it into a relational data store like Azure SQL database or dedicated SQL pool, for example. Serverless SQL endpoint. So how do we access Serverless SQL pool? Serverless SQL endpoint is provided by default within every Azure Synapse workspace, and you can immediately start querying your data using either Synapse Studio or usual suspects, as I like to call them, SQL Server Management Studio and Azure Data Studio. So let me show you a quick demo on how to connect to a Serverless SQL endpoint from Synapse Studio and from SQL Server Management Studio. So let me just put here, I'm in my Synapse workspace, and my Serverless SQL endpoint is provided here by default. And I can immediately connect here using Synapse Studio. So I can directly from my Synapse workspace click on open and just wait for a few seconds to get things up and running. Sometimes it's a little bit slower, but yeah, it usually works pretty fast. So I'm now in Synapse Studio, and here on the left-hand side, I have different tabs to go and explore my data. For example, if I go to manage, I can manage different resources. I will show you later what you can do in manage. For example, if you go to data tab, you will see all your linked services like Azure Data Lake Storage. And in my workspace, I have a SQL database, which is called Nikola Synapse, and different views. So I can immediately start exploring my data directly from Synapse Studio. So for example, let's say that I want to see what is in this CSV file. I can simply right click on it and select new SQL script and select top 100 rows. Synapse Studio will automatically generate a SQL syntax for me. I can run this from Synapse Studio, and let's wait for a few moments and see results. So as you see, we wrote, basically we didn't write, we used automatically provided script from Synapse Studio to retrieve data from our CSV file. Also, as I mentioned, you can connect from SQL Server Management Studio or Azure Data Studio. I will show you how to do it from SQL Server Management Studio. So I'm already connected, but basically it's just simple as you're connecting to a normal SQL Server database. You can connect to database engine, provide your Serverless SQL endpoint, and then, of course, your credentials for logging to this service. And it's, yeah, just simple like that. Okay, so going back to our presentation, let's talk now about, one of the key reasons why we are all here today is to examine how to leverage usage of regular T-SQL syntax for querying data that is stored within data lake. So let's check which options are available when using T-SQL in synergy with Serverless SQL pool. If we take a look at database objects, here is the list of objects you can create within Serverless SQL pool. The first and most important one are views. You will probably use them most frequently when working with Synapse Serverless SQL pool. You can also create multiple different schemas, same as store procedures. When it comes to user-defined functions, you can use inline table value functions. Additionally, you can create external tables, both regular and SSAS. Finally, you can create statistics on your data for increasing query performance. Things that are currently not supported are tables. Temp tables are supported now, but with so many limitations that I suggest to think that they are not supported. So many limitations, and they are not working even close to temp concept of temp tables that we have in on-prem SQL Server. The next feature that is not supported, and this is very important to keep in mind, is caching of query results. That means whenever you execute the query, engine will go and scan exactly the same amount of data. So no matter if you're playing around and press F5 once or 15 times for one single query, each time this query will generate exactly the same costs. Keep that in mind, please. And when I'm reading SQL related blogs or watching videos, Solfox, when they analyze execution plans, they talk about query cost. So you will often hear something like this query costs you 100 query bucks, this query will cost you 500 query bucks. Here, forget about the query bucks. We are talking about real bucks, real money. So you would want to think twice before hitting this F5 button for no obvious reason. You've probably already realized that Serverless doesn't support any kind of data persistency in between data lake, storage, and query result set. Therefore, you can't create objects like materialized views, unlike in dedicated SQL pool where this kind of intermediate storage is possible. Finally, you can't rely on objects like indexes or table partitions. You can partition files using file path function, but that's a whole different story. So there is no table partitions. If you're interested to find out more details about what is possible and what is still out of reach, I prepared some useful links for you, which I will share in the end. Okay, let me now walk you through what you can and can't do with T-SQL statements. A whole set of features, or let's say almost whole set of features for select statement is supported in Serverless SQL pool. You can also use explicit transactions on metadata objects and perform data export using SSAS statement. Apologize, I already mentioned SSAS on the previous slide. I didn't explain what's that. So SSAS stands for create external table as select. So you can think of it something like select something into syntax in regular on-prem SQL Server. So SSAS are very powerful feature. If you need to write cross database queries, that's also supported. And then whole set of T-SQL built-in functions, except those three you see on your screen, Open XML, Open Data Source, and Open Query. Finally, data definition language statements are also available. So create, alter, stuff like that, you can write this in Serverless SQL. What you can't do, you can't use insert, update, and delete statements. You can't perform merge within your queries. Within select statement itself, we said that almost everything is supported. There are just a few limitations. Namely, you can't use for XML, match, and predict functions. And also query hints are not supported. And finally, you can't combine data coming from system views with distributed data. Now let me show you where the serverless SQL pool excels and how you can quick and easy combine whole bunch of disparate data sources to perform data analysis without exposing real data source to your end user. So I'm here in SQL Server Management Studio, and you see that I have on the in my database I have a whole range of different views that I already created. So let me show you a few of them. For example, this one, this is CSV file. Let me show you definition of this view. I'll zoom it a little bit once it's opened, just for you to. So basically what I'm doing here, I'm writing select statement to retrieve data from a CSV file using an open row set function. And this CSV file is stored within my Azure Data Lake. I provide some additional parameters here. I will not bother you now with those details, but in the end, I'm getting results that you will see soon in the other demo. That's, for example, CSV. Then what I also can do, I can create a view over Parquet file using similar logic. But now this Parquet file is not stored in my Azure Data Lake. It's stored on some shared resource provided by Microsoft. I defined this external resource under external data sources here, this one. And basically I am retrieving data from this yellow cab, this public data set. And here in where clause I can use, for example, as I mentioned, file path to prune some data to retrieve only the portions of data that I need. In this example, as a first parameter of file path function, I want to retrieve year 2019, and as a second argument, I'm providing months of January and February. So you can basically write your where clause like you are used to do in normal SQL Server. Then I have the third view, which basically combines data from CSV and Parquet files. And that's a view. So when you show that to expose that to users, for example, in Power BI report, they don't see what's in behind. So they are connecting like to a normal SQL server. They're connecting like to a normal table, but they don't know that completely in the background are one CSV file and one Parquet file. I could also create a view over data coming from Cosmos DB, leveraging Synapse Link feature in Azure Synapse. I can also combine data from relational data storage, and I can put everything and mix that and create one view to include all the data from all the different data sources. And that's the real power of serverless SQL. Okay, so fine. So far we discussed what is possible, in which scenarios you would consider using serverless SQL pool, but we still haven't explained how to get the best from this engine, or what are the best practices for your data workloads once you decide to go this way and use serverless SQL pool. Let's start with a list of actions you should perform in order to maximize results of serverless SQL pool. First, default storage account and serverless endpoint are by default in the same region. However, if you are accessing other storage accounts or Cosmos DB analytics storage, if possible, try to place your serverless SQL endpoint and Azure storage accounts that you are targeting in the same geographical region. That will reduce the latency for the data's network transfer. Also, if possible, convert your CSV and JSON files to Parquet format. Parquet format compresses the data, and this consequentially leads to a smaller memory footprint of those files if you compare them to CSV. And additionally, Parquet is a columnar format. And in many ways, it resembles to a column store indexes in relational databases because each column is physically separated from the others. So because of that, serverless SQL engine can skip unnecessary columns when reading data from Parquet files, which is not the case with CSV. And this will directly affect not just time and resources needed for processing the query, but will also reduce the cost of that query. I'll show you later in one example. Next thing, built-in schema inference. That's one of the cool features in Serverless SQL, and it enables you to quickly query the data in data lake without knowing underlying schemas and data types. However, as almost every handy feature, this one also comes with a cost. And the cost is that inferred data types are usually much larger than the actual data types. For example, Parquet files don't contain metadata about maximum character column length, and inferred data type will always be varchar 8000. So I will show you now how to check inferred data types and how to handle this appropriately. So let's go back to SQL Server Management Studio. Let me just find this query. So I will use this SP describe first result set procedure. Let's execute this one and wait a few seconds for our Parquet file to see what's in there. For example, you can see that our vendor ID column is of varchar 8000. Why on earth ID column will be varchar 8000? So you can explicitly convert this instead of inferred data type of varchar 8000. You can explicitly convert this to integer or big integer or whatever you want. Also, you see also those location ID columns are also varchar 8000 and so on and so on. This is very handy query. This procedure is very handy because you can see the collation of the columns and other useful stuff. But I will leave you to investigate on your own about more details. Next one is, as I already mentioned, you can't partition the tables, but you can partition your files. And with that in mind, you can instruct Serverless SQL pool to target only specific folders and files using file path and file name functions. You saw in the previous example in where close how to use file path function to retrieve only some portions of the data. One important remark here, these two functions are currently, as far as I know, not supported for external tables, except those external tables that are automatically created in Apache Spark pool. Next one, take advantage of using SSAS. You learned what are SSAS whenever you can. This is one of the most important features in Serverless SQL. And using SSAS, you can store queries that are run frequently. You can store them to a new Parquet file and then use this single external table instead of referencing same underlying tables multiple times. So it's not a materialized view as we used to know in regular database, but it's still some kind of materialization. And this materialization happens within the Parquet file that is stored in the data lake. On top of that, as the SSAS generates Parquet format, statistics will be automatically created when you query your table for the first time. So you gain performance improvement for all subsequent queries that will target this same external table. Every do, as you might expect, has its counterpart in don't. So here is the list of things you should try to avoid or at least reduce to a minimum. When you are running queries on Serverless SQL pool, carefully plan other workloads that target your storage account. Serverless SQL, as I already said, has a built-in capacity to resolve. It automatically scales and has capacity to resolve these kind of issues by sending requests to your data lake at a slower pace, but that will obviously affect the performance of your query. Next, again, avoid schema inference. I know that it sounds appealing to just quickly get up and running without wasting time and effort to handle inferred data types, but you should definitely spend some time resolving inferred data types to appropriate ones, as you will reap the benefits later, I assure you. Get rid of single large files. Instead, split one large file into multiple smaller files and then use file name and file path functions to reduce the amount of data that needs to be scanned and processed. With that in mind, try to keep your single CSV file size between somewhere 100 or 100 megabytes and 10 gigabytes. In the end of this session, I'm also providing you with a link for best practices regarding Serverless SQL pool. Okay, so here we are. Do you know where does this picture come from? Remember Jerry Maguire? If you ask me, that's one of my favorite movies. And there is a great scene when Cuba Gooding Jr. asks Tom Cruise to passionately scream over the phone, "Show me the money, show me the money." So remember this picture, it's exactly what Microsoft will ask you to do. I'm kidding a little bit, but in the end, I know that majority of you stayed till this point with me to hear how much will serverless SQL cost. And I don't blame you. That's why I've intentionally left this topic for the later part of the session. So let's first examine what are you paying for when using serverless SQL pool. If you go to Microsoft official site, it boldly says that you will be charged for the amount of data processed. But let's dig deep and check what counts for the amount of data processed. The first thing is amount of data read. So here you should count data itself, but also related metadata for formats that contain metadata, like Parquet, for example. Then amount of moved data. So remember this illustration with control node and execution nodes. So when you run the query, query is being split into smaller chunks and sent to multiple compute nodes for execution. And while this query runs, your data is being transferred between the nodes, and these intermediate results is something that you should be aware of. Same as final data transfer to the endpoint in an uncompressed format. In reality, this number will differ if you run something like select star from the file that contains 100 columns from the case when you are selecting only a few columns. I will show you the difference in a minute in one example. Finally, amount of data written to data lake. This applies in those scenarios when you are using CSAS to export query results to a Parquet file that's going to be stored in a data lake. So when you sum up these three items, you are getting the total amount of data processed. Simple. Also statistics. As in regular SQL databases, statistics help the engine to come up with the optimal execution plan. And statistics in serverless SQL pool can be created manually or automatically. And in both cases, there is a separate query running to return the column on which statistics is built on. And this query also has some amount of data processed. One important thing to keep in mind here is with Parquet files, when you create statistics, only this relevant column is being read from the file. On the other hand, with CSV files, whole file needs to be read and parsed in order to create a statistics, even for one single column. And going back to our original request of showing Microsoft the money, currently pricing starts from $5 for 1 terabyte of processed data. The exact price might vary depend on the region, and you should definitely check how much would you be charged depending on where your data is. Also keep in mind that the minimum chargeable amount per query is 10 megabytes. That means even though you sometimes have a query that processed less than 10 megabytes of data, you will be charged as this minimum threshold was reached. Okay, so let's go and check different scenarios when querying CSV versus Parquet files, and also the difference between select star and selecting only a few columns. So again, going to SQL Server Management Studio, let's start with CSV. So I will just grab first this query that retrieves only 3 columns from my CSV file. So I'm picking up, let me zoom it a little bit, vendor ID, pick up date, time, and total amount. So just 3 columns. And if I go to messages, let me scroll it a little bit, you will see that total size of data scanned is, just try to remember those numbers, 755 megabytes, and data size of the moved data is 62 megabytes. So 755 and 62 megabytes. Now if I go to another one, which targets exactly the same CSV file, but now instead of retrieving only 3 columns, I'm using select star, which is, we know, bad practice, but that's just for the demo purpose. So I'm retrieving all the columns from CSV file. And if I now go to messages, Let's scroll down. And here you see that total size of scanned data is exactly the same. So 755 megabytes. But this time, instead of, I think it was 62 megabytes, now we have 668 megabytes. So it's 10 times more. That's the difference of because of the moving data between those execution nodes that executes the parts of the query, and data is being moved between those nodes. So when you sum up those two values, or to be more specific, those three values, so data scanned, data moved, and data written, in our case, because we are not exporting data anywhere, data written is 0. So when you sum up those three, you will get the total amount of data processed. That was for CSVs. Now I want to show you for Parquet files. So I have exactly the same portion of data stored in Parquet format instead of CSV. So let's go first and grab this one with only 3 columns. So again, vendor ID, pickup date time, and total amount. If we go to messages, you will see that now total size of data scanned is just 79 megabytes and data moved is 146 megabytes. Again, 0 here. So 79 and 146. Another similar example as in the previous case, retrieving all columns, writing select star. If I go to messages, you'll see that now amount of data scanned is 186 and data moved is 720. So what are the conclusions that we can draw for those from those test runs? When we are talking about CSVs, if we run something select star versus select column 1, 2, 3, the amount of data scanned is exactly the same. That means it doesn't matter what you do with CSV files. Each time the whole file will be scanned, each time. So it doesn't make the difference. But the amount of data moved is different. With Parquet file, in the same scenario, amount of data scanned is different. Why is that? Remember, Parquet is a columnar format. So basically, when you write select column 1, column 2, column 3, Serverless SQL engine is smart enough to omit those unnecessary columns and then just take data from those 3 columns that we want. So it will not go and scan unnecessary columns, only those that we want. And amount of data moved is also different. So these are some numbers that I ran in the previous test, but it's quite similar to those conclusions that we saw in our example here. Okay, so why is that? Just let me go quickly here and explain one more thing. Why is this amount of data moved higher in Parquet file than in CSVs? Because Parquet contains metadata, and remember there is a query that also runs over metadata to retrieve the metadata. That's why it is slightly higher here. So 50 megabytes and here is 80 megabytes. Okay, so let's now go through the list of the items that goes on house, or if you prefer, that Microsoft will not charge you for. So what doesn't count as amount of data processed? First, querying server level metadata, stuff like logins, roles, server level credentials, and so on. Also, databases you create within your serverless SQL endpoint, as these databases contain only metadata, users, schemas, views, stored procedures, definitions, external data sources, external file formats, and so on. Also, metadata related queries because they don't process data from the storage. And finally, DDL or data definition language statements such as create or alter, except create statistics, which I already explained how it works in serverless SQL with CSV versus Parquet. Okay, so how do you control your costs? The first and most important feature that you can set is the maximum threshold for amount of data processed. The number you define is in terabytes, just to be aware, and you can define the maximum amount of data processed on daily, weekly, and monthly level. How it's done? You can do this either through user interface in Synapse Studio or executing T-SQL statements in your tool of choice. I still prefer SQL Server Management Studio to Azure Data Studio, so let me quickly show you how it's done both from Synapse Studio and SQL Server Management Studio. So I will go to my Synapse workspace, and here, if I go to Synapse Studio, under Manage, you see this built-in. That's what I talked in the beginning. So once you provision your Azure Synapse workspace, this serverless pool will be automatically provided to you. So if I hover over here, you see this small icon showing some money and settings. So I will click on it, and then on the right-hand side, I can see the total amount of data processed today, this week, and month. And you see this. Oops, sorry. So you see that my daily limit is 1 terabyte, my weekly limit is 2 terabytes, and my monthly limit is 30 terabytes. So I can change, for example, here and select 1 to 3, so 3 terabytes on a monthly as a monthly limit. Apply this, and this will be immediately applied. So this is how you check here in Synapse Studio. If you go to SQL Server Management Studio, let me just find this one. Yes, so I can use this SP set data process limit procedure, providing two parameters, type and limit in terabytes. So for example, I will first check what are the current limits. So I will check current limits from sys.configurations. You see that it's, let me zoom it a little bit. Daily limit in terabytes is 1, 2, and 3. Let's set this one to 30 again, and I will execute this store procedure. Let's check again, and you see that it's now 30. So you can also set your limits and check current limits from SQL Server Management Studio. You can also check current amount of data processed. So you saw in Synapse Studio, you see the number in gigabytes. But here I was playing around and include some calculations to convert the amount of data processed to real money. So if I run this query, you will see that today I processed 4.5 gigabytes of data on a weekly basis, the same, and this month is slightly more. And this the last column is basically multiplying this amount of data processed in terabytes with $5 per terabyte. So this last column shows that for you this session is free. For me it's not. I will need to pay this money to Microsoft in the end. Just kidding, of course. That's trivial amount, but you can check the real money that you spent on a daily, weekly, or monthly basis. Okay, fine. So where to go from here? Now, I guess there was a hell of a lot of information to absorb in less than an hour. I mean, we covered whole range of different topics, from traditional versus modern data warehouse, and then Synapse Analytics architecture, all the way to best practices for serverless SQL and cost control. Oh yeah, we even talked about Jerry Maguire. Remember that? And it's completely fine if you are still not sure whether a serverless SQL pool is the proper answer to your analytical workloads. So I prepared a list of useful resources that you can always refer to and find answers to, well, if not all, then hopefully most of your questions. Of course, feel free to ping me or get in touch in case that you need any further clarification, or if you just want to talk about Synapse Analytics. I'm a huge fan of it and would like to chat with you about it. That's it from my side, and yeah, looking forward to hearing your questions if there are any. I'll switch now to chat window and check in case that there is not enough time to answer all of the questions, or if I don't know the answer right now, which is also quite possible, I will collect all the questions and try to get back with the answers later.
So Max has a question as far as, can you have the external data sources from DBMSs like SQL Server and Oracle that are on-prem?
As far as I know, you can, yeah.
And that's it. If you have any questions, feel free to post them in the chat window. and we'll ask them. Ryan has a question. How does the distributed query process handle data that is being written and changed while it is being read?
That's a good question. I don't know the answer. Honestly, I don't know the answer. That's a good question. I need to check this. Sorry, Ryan, I don't know.
And Nico says, have you worked with D365 F&O Azure Data Lake services?
Fortunately or unfortunately, but I think fortunately not. But I would like to hear experience if Nico knows something that to change to share with us. I would like to hear experience. Very fortunate.
You're fortunate for not having to have work with it.
Yeah.
Well, we'll just stay on for a little bit longer. Here we go. Max, will the costs be lower if you are querying an external DB engine since you are using Synapse just to combine the data?
If you can be more specific, how do you think? What do you think under querying external database engine? If you think like something like, I don't know, SQL Server or Oracle or something like this?
Yeah, I think he's saying if you're querying on-prem and just combining it in Synapse, would the cost be less?
Well, every time when you are running serverless SQL pool, so whenever you execute the query, basically the same amount of data will be scanned. So maybe will be lower if you prepare a data in advance just for consuming via serverless SQL pool. So if you, I don't know, if you need to combine data from 5 tables, if you're able to create a materialized or indexed view in the source database, then serverless SQL pool will have to deal with smaller amount of data and to process smaller amount of data. So in that case, it should be lower costs. But other than that, if you are just querying tables normally, then each time it will generate exactly the same costs.
Okay, and does Synapse add overheads compared to processing like SSIS or C# scripting?
It's not comparable. So serverless SQL is not something that you would use instead of SSIS. So basically for that purpose, I would rather compare Azure Data Factory and SSIS. Serverless SQL has completely different use cases, basically. So it's not something with SSIS. You are doing ETL stuff in a traditional way. With serverless SQL, you can do ETL stuff, but just on a logical layer, so you don't have like materialized transformations in between. I hope that this helps. Aha, Max. Yeah, if you offload most of the processing to an external engine, in that case, yes, the costs should be lower. Are there any features not yet implemented you are waiting for? Yes, personally, I'm eagerly waiting for result set cache to be implemented, as that will significantly improve both the performance and cost, reduce the costs. But keep in mind, so not just serverless, but Synapse as a whole is a work in progress. So there really adding a lot of new features each. Now it's on a monthly level, so there you can follow them and then see that on a monthly basis they're releasing new features and updates and improvements. So it's a work in progress, and they're going to a good direction. It's still not finished thing. It's not a polished thing, but basically it's a good integration environment for doing everything related to data.
That sounds great. Thank you so much for this lecture. It was extremely well received. And I love the question about the features that are not yet implemented. I thought that was a great question and a great answer.
Indeed, yeah.
Things to come. So that's wonderful. Thank you, Nikola, for your evening time and spending it with our group. We will be posting this recording over to our YouTube channel and getting it there, before the weekend. So thanks again for your time, and we'll see you in another couple of weeks.
Thanks, Julie, for moderating, and thanks everyone for joining. Have a great day and good night.